Okay, 2, 3, and now we're going to look at number 13. And it says, on this graph, is the function increasing on the interval from -8, so x, -8, to -2? Is the function increasing as we go left to right? Yes, it's going up, so yes, it's increasing. On 14, is it decreasing from -8 to -4? From the interval -8 to -4, which is here. Is it decreasing? No, it's going up. It's increasing. They just asked us that. Is f increasing on the interval from -2 to +6? From -2 to +6, it decreases, increases, decreases. So is it always increasing? No. Is f decreasing on the interval from 2, remember, the intervals are always in terms of x, from 2 to 5, is it decreasing? Yes, it is going down. 17. Is it, list the intervals on which f is increasing. Okay, I'd have to say from -8 to 2, not including. This is where it's increasing. And it's also increasing from 0 on the x to 2 on the x. And it's also increasing from 5 to 7. Always looking at the x's for intervals. 5 to 7. And you never put square brackets for increasing, because if it's stopping, then it's not increasing there anymore. And list the intervals where it's decreasing. This is number 18. So it's going down from x being -10 to -8. The function's decreasing. -10 to -8. Then it decreases again from -2 all the way up to 0 in the x. -2 to 0, it's decreasing. And then it decreases again from +2 in the x to +5 in the x. And that's 18. And finally 19. Is there a local maximum at 2? Yes, it's yes. What is it? It's 10 at x equal 2. The local maximum is 10. And let's see, next one, 25. So 25, we have a graph way down here in the corner. I don't know if I can get that under the camera. I'll try. There we go. I think. Okay, there's 25. And it asks on 25, intercepts. X-intercept -2, 0 and 2, 0. Y-intercept 0, 3. Domain. The domain goes from -4 in the x's all the way to +4. And it's inclusive, so I better make square brackets because it has solid dots. That's the domain. The range is the next question, or part of this question. So the lowest y value is 0 and the highest y value is 3. And there's solid dots on both of those, so 0 to 3. Interval in which the function is increasing. So it's increasing from -2 to 0. We always look at the x's. -2 to 0. and from 2 to 4. Then decreasing. It's decreasing from -4 to -2. And from 0 in the x to 2 in the x. Is the function even, odd, or neither? Well, this one, you get if you put it in a +2 or a -2, you get 0. You put a -4 or +4, you get 2. Same thing. So when you get the same result out for either a positive or negative of the same number, you have an even function. So it's even. That's 25. 29. We have the same directions. So let's put it up on 29. And it asks, domain goes from -pi to pi with square brackets. Range goes from -1 is the lowest spot to the highest spot is 1 with square brackets because it's solid dots. Next question, first question is intercepts. -pi 0, 0, 0, and pi 0. Those are the intercepts. X-intercepts, and 0, 0 is also a y-intercept. Intervals where the function's increasing. It's increasing from the x value of -pi/2 to x value of pi/2. That's where it's increasing. Decreasing, -pi, square bracket, to -pi/2, curve brackets. The intervals of increasing, decreasing are always curve brackets. So it's decreasing from -pi to -pi/2 in the x's. And from pi/2 to pi, decreasing. It's never constant. And is it even or odd? This one's odd because if I put in pi/2, I get 1. If I put -pi/2, I get the opposite of 1, -1. And if I put in -pi, I get 0. And if I put in +pi, I get the opposite of 0, which is also 0, etc. Or you can also say it rotates 180 degrees on itself. Or for anything over here, I have a matching on the opposite side of the origin. So that was 29. The next one is next one is, let me see here, 35. 35 is this graph, and it asks the numbers, if any, in which f has a local, the numbers, if any, at which f has a local maximum. So now they're asking for the x value. And what is the local maximum? So there's a local maximum at pi/2, and the local maximum is 1. That's where stuff will get trapped. Gas will get trapped. And B, is there any local minimum? Yes, it happens at -pi/2, and what is the local minimum? -1. That's 35. 37 is different one. 37 is, it asks, let's change to paper on this now. 37. So I got to zoom out a little bit. It says f of x is x for x to the third. Is it odd, even, or neither? A good way to kind of check is to put in -2 or -1. -2 to the thirds, that's -2 times -2 times -2, which is Negative times negative times negative is a negative. 2 times 2 times 2 is 8. So negative 8 times 4 is negative 32. Now let's put in plus 2. 2 times 2 times 2 is 8, times 4 is 32. I got the same size number, but one, it changed in sign when I changed the sign of the x, so it is odd. And that's how you can check and kind of get an idea. That was 37. 39, we'll do the same thing. So we have g of x is negative 3x squared minus 5. If I put in 2, 2 squared is 4 times negative 3 is negative 12 minus 5 is negative 19. Let's put in negative 2. Negative 2 squared, negative 2 times negative 2 is positive 4 times negative 3 is negative 12 minus 5, negative 19. I changed the sign of the x, I got the same number out. That's an indication that it's even. Okay, and let's see here. Is that in the picture? Yes. All right. That was 39, 42. Square root of x. If I put in a positive, let's say put in a positive 4 because I'm doing square root, and the square root of that gives me 2. If I put the negative 4 in, I can't do it. It's undefined. So it didn't give me the same, didn't give me the opposite, it gave me something impossible, so it's neither. Okay, and then the next one, that was 42, 47. It said x to the third, negative x to the third over 3x squared minus 9 for h of x. So let's put in 2. 2 cubed is 8, so, and with a minus, so it's minus 8 over 2 squared is 4 times 3 is 12 minus 9 is 3. So we got negative 8 thirds. Now let's put in negative 2. Negative 2 times negative 2 times negative 2 is negative 8, and then a negative of that would be plus 8. And I put negative 2 in the denominator, I get 4. 3 times 4 is 12, minus 9 is 3. So I get positive 8 thirds. Changing the sign of the x, change the sign of the y. That's an indication that it is odd. It's symmetric with the origin. Whatever it does up here, it does down here, and whatever up here has the same thing down there. That was 47. 49. Now we got a picture again. $49. Zoom in again. Pull this over. And it says, find the absolute maximum and absolute minimum if they exist. Identify any local max or mins. Okay? Absolute max. Very highest place. It's 4. Look at the y values when you're looking for absolute max, absolute min, or local max or local mins. Absolute min. Very lowest place is 1 high. Happens at 5 if you want, but now it says, is there a local max? So is there a place where gas will get trapped? Looks like it's about 3. Is there a local min? And it looks like that would be a puddle at 2 high. And that's it. That's 49. Then we got to do 52. This one has a absolute minimum of 1, absolute maximum looks like it would have been 4, but there's a hole, so no absolute max. Is there a local min? Is there a place where stuff will puddle? Nope. Is there a place where the gas will be trapped? It'll leak out there, so no local max, no local min, no absolute max, just an absolute min of 1. That's 52. 55. This has, 55 is this one. There's no absolute max because there's a hole there. So no absolute max, no absolute min because there's a hole at the very lowest spot, no -3. Is there a place where the gas will be trapped for an local max? Nope, it'll leak out. Is there a place where water would collect? Nope, it would leak out. No absolute max, no absolute min, no local max, no local min. That's 55. Now we're on to 58. Use a graphing utility to graph these over the interval and approximate any local max and min values in determining where the function is increasing and decreasing. So you pull out the calculator, you push y equals, you clear and put in x to the third minus 3x squared plus 5. And then I push zoom 6, and I could actually zoom in a little bit more, but I don't need to. And they want me to look from -1 to 3. Looks like there's a local max right there and a local min right there. And the function's increasing from -1 to 0, decreasing from 0 to 2, and increasing from 2 to 3. And that's kind of what they want to do. What is that local max? So I would go secant, calculate the maximum. The calculate's above trace. And I want to say it looks like it's about 0, so it must be between -1 and 1. So I push -1 for the left side, 1 for the right bound, and I want to look between there at about 0, and it says 0 is where it is maximum, and it is a maximum of 5. That's how high that is. Now how low is that? Looks like it's about 1. It's between 1 and 3, so I'm going to go secant, calculate the minimum between 1, enter, and 3, enter, and it looks like it's about at 2, so I'm going to press 2 for my guess, enter, and it says yes, the minimum is at 2, the minimum is 1, and that's 58. And it's now 65. Now to find average rate of change, you just find the slope. So, okay, it was not showing there, so let's move it up. Average rate of change. And so f of x is minus 2x squared plus 4. So I find f of 0, which is 0 squared 0 times minus 2, 0 plus 4 is 4. So I have the point 0, 4. And then I find at 2, so f of 2. 2 squared is 4 times negative 2 is negative 8 plus 4 is negative 4. So I have 2, negative 4. So the average rate of change is the slope of this secant line. So the change in y, that goes from 4 to minus 4, that's down 8. Change in x goes from 0 to 2, that's plus 2. So the average rate of change is negative 4. Then it says do it from 1 to 3 and then from 1 to 4. So you do the same process. Plug in 1, get the y value. Plug in 3, get the y value, and find the slope. Plug in 1, plug in 4, find the y values, and find the slope. That's what it means to do the average values. 71, doing the same thing with just some different things, numbers, but that's the idea.